Welcome back. Today we're going to be doing lesson 2-6, day 1. We're skipping ahead a few lessons and then we're going to come back and do 2-5. So today's lesson is about algebraic proof, and in order to be able to solve equations, we need to know some properties of real numbers. So we're going to start with the addition property. So we've actually used this quite a bit, but we never really formally talked about it. It's the addition property of equality. And what that means is if something is equal, well, here we have A equals B, then we can state that if I add C to A and I add C to B, we actually get a true statement. And the second one is our subtraction property, also of equality, which also states similar to this one, if A equals B, then A minus C is equal to B minus C. Next one is our multiplication. Property of equality. And similarly, if A is equal to B, then A times C is equal to B times C. Division is our next one. And in this property, what we're going to be looking at is if A equals B, and as long as C is not equal to 0, then A divided by C is equal to B divided by C. Alright, now we've started getting into some ones that we're actually going to probably be more unfamiliar to you. So the first one is called the reflexive. And so the reflexive property of equality states that whatever you have on one side will kind of be reflected over on this side, and how we see that is a reflection over the equality symbol. So we could have something like C equals C. That's a reflexive property. We're seeing the reflection on the other side. So our next few here are, again, these ones are probably new to you, symmetric. And this is of equality again. So the symmetric property says if A equals B, then B equals A. So there's some symmetry in here that we have. All we're doing is really switching the sides of the equation, and we still have the same property here. So next is called transitive. And you can think of transitive as kind of being on kind of like a train. So if A goes to B and B goes to C, well, then we can make a statement that A also goes to C. In math terms, we would say this is A is equal to C. So we're adding this little piece in here that if B is equal to B, then we could say that just A can skip all the way to C. The next one is substitution, and you're probably familiar with this one. We see this quite a bit when we try to solve by plugging in. So if A equals B, then A may be replaced by the substitute of B in each equation or expression. And the last one, I think you're probably familiar with this one as well, it's called the distributive. So the distributive property is the one often seen like this, and it says if A parentheses B plus C, then this is equivalent to taking A, multiplying it by B, plus A multiplying by C. And oftentimes we just see it like this, AB plus AC. Oftentimes, we also see it like this. We get a B here and a minus. So this is also true. It would be AB minus AC. So oftentimes we just forget sometimes that it also needs to go to that last term. So we're going to be using all of these things to solve equations. So when we talk about proof, we're usually going to have two columns. We're going to have our statement, and we're going to have our reason. So the only thing that's really new for us is that we're going to have to state, why is it possible? So why can we do this? So it's the reasoning behind what the statement is. So always the first thing is we're always going to write given, and then you look up above and you see, okay, well what do they tell us? So they tell us 2 parentheses 5 minus 3a is minus 4 parentheses a plus 7 is equal to 92. So all the time in your proof, you're always going to start with what is given, every single problem. The second thing that you want to do is to look for, if you're going to solve the equation, what is the correct order of operations, or PEMDAS. So in this problem, I want you to notice that if I think about PEMDAS, I really have to use my distributive property first. So that's our reason. And we're then going to go into just using the distributive property and writing what I'm going to get after I distribute. So I'm going to get 10 minus 6a. And then over here, we're going to get negative 4a and minus 28. So oftentimes people forget to take that negative and multiply it to that 7, so just be careful. If you want to make sure that you don't make that mistake, one option would be to go change this to a plus and just scoot a little minus up to the 4. That will help remind you that you need to distribute the negative also. Alright, and that is going to equal 92. Alright, so it looks a little bit better. We have that's an equal sign, and the next thing, I really just need to combine like terms. And so I could say a couple of things here. We could say we're going to use the addition property, but it's not of equality yet, so we're just going to say combine like terms. That also, you can also say simplify. But you have to give a reason for what you're doing. Alright, so I'm going to take the a's and connect them together, and then I will take the 10 and the 28 and get that. Alright, so when we use equality, this is where we either add or subtract to both sides, and from here on out we can use our properties of equality. So if I'm looking at this next part here, I want to know if I'm trying to solve for a, well, I would have to add 18 to both sides. So therefore this is the addition property of equality. And then you would write what you have after you do that. So we would get negative 10a equals 110. Alright, the next step, we look, okay, well, what I have to do next in my equation, it looks like I need to divide by negative 10. So this will be the division property of equality. And I would get a is equal to negative 11. Alright, once we get down to that part, we are actually done, and we'll move on to the next one. Okay, so the first thing, and again, this is your first time going through this, so we write statements. Over here we're going to write reasons, and we're going to start by always number 1 is going to be given. So we'll start with our sentence. Alright, again we're going to be using our order of operations, so we need to start with figuring out the first step here, which would be distributive property like we saw in the last one. And the second thing you're going to do is just remember that when you're using your distributive property, just make sure your negative goes with when you distribute. So we would have negative 3a minus 9 plus 15 minus 5a is equal to negative 50. So the next thing we need to do is combine like terms. Sometimes we could just say simplify. And then we are going to put our like terms together. So we would get negative 8a. 15 would give me a positive 6. Alright, so the next step we're solving for a, so we need to get rid of the plus 6. So to do that, we are going to use our subtraction property of equality. And we're going to subtract 6 from both sides. And then we're going to write what we get. So we get negative 8a is equal to negative 56. Lastly, our last step is to divide. So we're going to use the division property of equality. And then we'll just go ahead and divide. So when we divide negative 8 by both sides, we get a is equal to negative, or just 7. And we are done. So I was going to go through the next problem, but I think I'm just going to skip that one because we've taken up kind of a lot of time on this video. You can go ahead and just look at those two, and we would do the same thing. And I'll just put the notes in Schoology, so you can just go ahead and look at those examples, but I'm not going to go through them. Alright, that's it for today, and we will talk later.